look at how can we solve exponential equations, and the first strategy we look at is using a common base. So if we look at the following expression, I have 9 to the power of 2x plus 3 divided by 27 to the power of 3x minus 1 times 81 to the power of x minus 1. We can simplify this expression by changing everything into a common base. What common base do you think we should look at? 3. Because if I look at the numbers 9, 81, and 27, 3 should be the number that kind of stands out. So how do I write 9 as a power of 3? 3 squared. So instead of 9, I'm going to write 3 squared to the power of 2x plus 3. What would I write instead of 27? 3 cubed. And then that would be raised to the power of 3x minus 1. And then how do I write 81? 3 to the power of 4. And what is the rule when I raise a power by a power? What do I do to the exponents? Multiply them. So now I have 3 to the power of 4x plus 6. And what would the next one be? 3 to the power of what? 9x minus 3. And the last one would be 3 to the power of
x minus 4.
Good. Okay. If the bases are the same and I'm dividing the powers, what do I do to the exponents? Subtract them. So if I subtract them, what is 4x minus 9x? So it's 4x minus 9x.
Negative 5x.
Negative 5x. And what is 6 minus negative 3?
9.
9. So I get 5x plus 9. When the bases are the same and I'm multiplying the powers, what do I do to the exponents?
Add them.
Add them. So if I take, sorry, there should be a negative 5x here. If I take negative 5x and I add 4x minus 4. So it's negative 5x plus 4x. Negative x. And what is 9 plus negative 4? So my simplified expression becomes 3 to the power of negative x plus 5. Okay? So an exponential equation is an equation where the variable is in the exponent. This is an exponential expression. These were all exponential expressions because the variable appeared in the exponent. When we want to solve an equation where the variable is in the exponent, what we want to do is we want to use common bases. So we want to try to rewrite the bases so that they have a common base, like taking 81, 27, and 9 and writing them all as bases of 3. Because if I have 3 to the power of something equals 3 to the power of something else, these two exponents are going to have to be equal to each other. So then I can ignore the base and just concentrate on letting the exponents equal each other and solving for the missing variable. So if we look at class example number 1, we have 5 to the power of 2x plus 3 equals 5 to the power of 7. Because the bases are the same, if these two exponents are equal to each other, the exponents themselves have to be equal to each other. So if the powers are equal, the exponents will have to be equal. So I can ignore the 5 of the base and just look at the exponents. How do I solve solve this? And when I subtract both sides by 3, I get 2x equals, and then what? So x would equal 2. And if I put 2 back into that expression, 2 times 2 is? 4. And 4 plus 3 is? 7. Does that equal the other side? Yes. So if I look at B, I have 7 to the power of x minus 1 equals 343. So I don't have a common base, or I don't have the same base, so now I want to find a common base. So what base do you think I'm looking at? 7. Because I can't write 7 as anything else. So the question is, can I write 343 as a power of 7?
7 to the power of 3.
Good. So now that I have the same base, I can let the exponents equal each other. And what would x equal? 5. And if I go 5 minus 2, I get 3. And 7 to the power of 3 gives me my 343. So if we look at C now, 3 to the power of 5x minus 1 equals 81 to the power of 3x. What is my common base? Okay. And 81 becomes 3 to the power of what? 4. And then that's raised to the power of 3x. So if I simplify this side, what do I do to the exponents on the right-hand side?
Multiply them, so it'd be 12x.
Right. And now I have a common base, which then means I can let the exponents be equal. And then I can solve. So how would I solve this? So subtract by 5x, and what would I get on the right-hand side when I subtract 12x by 5x? And then, so x would equal, good. Take a look at D. What is my common base that I'm going to use with D? So 3x will stay as it is. What will 27 become? 3 cubed. And what will the square root of 3 become if I write it as a power?
3 to the power of 1/2.
3 to the power of 1/2. Good. When the bases are the same, what do I do to the exponents under the multiplication rule? I add them. So what is 3 plus 1/2? How many halves would I have altogether if I added 3 wholes and then 1 more half?
7 whole.
7 halves. So I'll have 3 to the power of x equals 3 to the power of 7 halves. So then x would equal 7 halves. Okay, so we have a couple more examples to go through. Bacterium triples every 6 days. The number of bacterial present after x days can be given by the formula n equals 3 to the power of x over 6. After how many days are there 243 bacteria? So the number 243, what variable does that represent? My n or my x?
N.
n. So 243 will equal 3 to the power of x over 6. So what common base do you think I have to use? 3. So now I need to figure out 3 to the power of what equals 243?
3 to the power of 5.
So now I have common bases. I can eliminate them. And I get 5 equals x over 6. So how do I get x by itself?
Multiply both sides by 6.
Do what to both sides? Multiply both sides. And so then x would equal
30.
30. So class example number 4, we get into some fractions. We still follow the same process. Ignore the fact that we're dealing with fractions and just look at what these bases are, 27 and 81. What do you think my common base is going to be? 3. So 27 is 3 cubed. Now with this 81, 81 is 1 over 3 to the power of 4. So I get 1 over 3 to the power of 4 to the power of x plus 3. So now I multiply my exponents. I get 3 to the power of 3x minus 1 over 1 over 3 to the power of 4x plus 12.
Why is it 3x minus 1? Shouldn't it be?
3x minus 3, sorry.
Shouldn't it be 3x minus 6?
Yeah. And I forgot to do attendance.
We're all here anyways.
So the problem, or not the problem, the issue that I have is realistically I don't actually have common bases because the base on this expression is a 1/3. So how do I make this base equal to 3? In other words, how do I bring the 3 up to the top? I make the exponent negative. So 3 to the power of 3x minus 6 becomes equal to 3 to the power of negative 4x plus 12, if I put it in brackets, which then would become negative 4x minus 12. So now I'm going to give you a moment and I want you to solve that. So when I go to solve this, I get 3x minus 6 equals negative 4x minus 12. Probably easiest to add 4x to both sides because it would be, I'm dealing with positives. So 7x minus 6 equals negative 12. Add 6 to both sides, and I get negative 6. So x becomes negative 6/7. And I could check this. I could put negative 6/7 into the exponents and see if the left-hand side does equal the right-hand side. Finally, if we look at B, I have 125 over 216 to the power of negative x over 4 is equal to 6 over 5 to the power of 3x minus 3. How do I figure out what my common base is going to be? What hints or what strategies could I use?
Won't it probably be 6 over 5 because it's a fraction?
It's probably going to have these 6s and these 5s. So 125, do you think that's going to be a base of 6 or a base of 5?
5.
Base of 5. 5 to the power of what?
3.
3. So then 216 should be a base of 6. 6 to the power of what?
6 to the power of 3.
6 to the power of 3. So I can rewrite this as 5 over 6 to the power of 3 to the power of negative x over 4 equals 6/5 3x minus 3. So then I would multiply on the left-hand side the exponents to get negative 3x over 4. Now when I get to this point, I've simplified, I've used common bases, but the bases are not equal to each other. Can I make the bases equal to each other? How could I make them equal to each other? What can I do with this? I could flip it. But if I flip it, what do I have to do? It would make the exponent positive. So 6 over 5 would now be to the power of 3x over 4. And then I get 6 over 5 to the power of 3x minus 3. Now I have the same base, so now I can let the exponents be equal to each other. How do I solve this?
Times both sides by 4.
Times both sides by 4. Good. Get rid of that denominator. So if I multiply both sides by 4, I get 3x equals 12x minus 12. Then what would I do? $12 or 12x. Okay? So what's 3x minus 12x? So I get negative 9x equals negative 12. So then x would equal negative 12 over negative 9. The negatives would cancel, and I'd get 12 ninths. Is that simplified?
4/3.
4/3. And it is, we do have to simplify it to 4/3. We need to make sure our fractions are in simplest form. So these are the questions. 1A, 2B, and F. 4 and 5. Question 6C and 6C. And then 9 to 12.